to thank everybody for showing up. I'm honored to talk to you, so much so that I'm actually wearing a clean t-shirt and jeans, so that is formal wear as of late. So the topic we'll be talking about is data visualization with PyGal. A real brief agenda, we'll just talk about what PyGal actually is. Then we'll go over just a couple of slides of graphing basics so that we're kind of talking the same language. And then the remainder of the slide deck is primarily just a sampler of the types of charts and the code to generate it. For me, part of the reason I'm interested in this is the last couple of contracts I've been working on, I've been responsible for digging through debug logs and trying to attain system performance behaviors from the existing logs. And one can say visualization of even the most modest data sets really gives you a better understanding of the whole. So in this last couple of years, I found myself at a Coursera course trying to kind of hone in on my data visualization chops, and it introduced me to PyGal, which I had never heard of before. PyGal is a Python module. It creates these interactive SVG graphs, and it's one of many. I mean, matplotlib was about the library that I knew most prior to that, and there are a few others that I'd like to spend some time on, including Seaborn and Plotly. But it generates these simple interactive charts that are readily integrated into web interfaces because PyGal basically creates an HTML file, and then you use your browser to actually interact with the chart. So graphing basics, I don't want to spend much time on this because I'm sure you know all of this, but just terminology. The title is atop. The legend on the left-hand side identifies that this is a multi-series graph. We got our X and Y titles and our X and Y axes. But one thing that I want to try to use the term X categories and Y categories, because I think most graphs that we actually see are numeric in nature, so sometimes they're called ranges or ticks or whatever. But we'll see later on that they can just be a discrete set of values. So categories seems to be a little more appropriate. And this is the only other slide we'll do on graphing basics, but we are going to be talking about two-dimensional graphs. So in particular, that means that you need an X and a Y component. There are subtle differences in PyGal and probably other languages or libraries about how those values are specified. For things like a scatter point graph or an XY graph that we'll be seeing later, those values are added to the chart in a series of tuples, right, or pairings, X and Y pairings. But most of the graphs that we're going to be looking at really come in the form of just Y values, because the X values are inferred by the position of the X categories. And in the next slide, it'll be a little more apparent. So this is probably one of the simplest PyGal examples that you may play with, right? Line 2, we import PyGal. Line 3, we create a chart. And then after that, we can modify or add edit the title and the X labels. That's what PyGal calls what I'm referring to as X categories, right? In this particular case, we're defining our X-axis as a range from 2002 through 2012. And then when we get to line 6 is when we start specifying our Y components. So we add to the chart this series. This series, on line 6, we're calling that our Firefox series. And you'll notice that the first two elements are none, implying that Firefox didn't have any market share or values for those first 2 years. So 2002 I've got none, 2003 I've got none. Only in 2004 did Firefox exist, and it has a value of 0. So that's how the pairings kind of work. And then way down on line 10, that's when we actually render this in a browser. So what that does is it generates a temporary file and opens it with your default browser. The end result is kind of the chart that we're seeing, but with interactive components, which, you know, in a future slide I'll try to demonstrate what that means. But you know, you can hover over data points, it'll tell you the value, you can zoom, pan, those kind of things. So that's the browser actually gives you that capability. In search of trying to put together an interesting enough presentation, I didn't want to just create artificial data. So I sought out kind of an interesting data set to deal with. And the first one I came across was this 538 wrote a paper called The Economic Guide of Picking a College Major. And part of the appeal was they had a CSV file, and it seemed like an interesting thing. It's just an interesting data set. I'm not endorsing the paper. I didn't even read the entire paper. I just read enough to understand what the values were. And I was hoping that this would be a deep enough data set that we can kind of show different types of information in different forms of graphs. This will be the couple more, and then we'll actually get into real code. But that data set had like 174 rows and 21 columns, but we're really only interested in like 9 of them. In particular, what we're focusing in on here is they basically identify all the majors from a college, and they kind of rank the viability with respect to economic factors. But the rank we don't really care about. What we're really going to be looking at is the major code, which is a unique identifier for the major title, and then the students, both by total and a breakdown of men and women participants, and then unemployment rate and like the median. So this is partially what drew me to this data set. It's got a lot of interesting stuff, and I thought it would be a good fit for the type of graphs that I thought would be interesting. This slide is my shame. While I'm relatively familiar with the Python CSV module, that Coursera course basically sent you home with homework that you needed to create a method that read in a file, and then when specifying a key field, it would return a dictionary of dictionaries. So in this particular case, that primary key we were talking about was the major code. When you specify that, it returns 1301 is the major code, and a sub-dictionary with the rest of the interesting fields. I say this is my shame because in retrospect, I've only recently become more familiar with the Pandas CSV reader, and I probably would have utilized that, but I move forward with what I have, and look forward to spending more quality time with that module in the future. But the good news is even though I'm not really happy about how the data is coming in, we're not going to be focusing on that much. We're mostly just interested in the field so you can understand what the graph is trying to represent. So far so good? I'm a fast talker when I'm nervous, so tell me to slow down if you need to. All right.
Yeah, it sounds great, Grant. Actually, we had a question from David. Noel, is PyGal compatible with Jupyter Notebook?
I have seen it used with the Jupyter Notebook, so yes. In order to get it to render on the notebook, there's a use statement that needs to be done, but yes. I'd give you more details, but I tend not to use the Jupyter Notebook or the online notebooks very much, but I'd be happy to help if you want to give it a try. Continue, or any other questions? Okay. Well, we'll jump down to line 12, and you're going to see a lot of similarities with the rest of the slides. So, but in particular, line 12, we actually create our chart. In this particular case, a line chart. And then you notice in line 15, we actually start adding our data series. And rather than spend time on how the dictionaries are laid out and the like, if you look at the bottom right, that's how these statements would, essentially evaluate. I have a chart. I want to add women is my series title, and then a series of or a list of Y components, followed by men, followed by total, and as we had seen in the slide, a couple of slides back, if we look at these four statements, that basically means that 2416, the major code 2416, had 77 women, 679 men, for a total of 756. And when we render it, we get the chart that is presented in the slide. And that's one of many, but let's move on to something else, a stacked line, different type of chart. The syntax is identical, so the only difference between this and the previous code snippet is line 12. We specify a fill as true because we are implying that we want to color the region underneath of the line. So that's another alternative for data presentations. We love the old bar chart, so identical in nature. Once again, only difference is in line 12. And of course, a horizontal chart as well. You will notice that, what you're trying to depict and how you're depicting it, and your choice of chart sometimes really go hand in hand. You'll notice what I'm trying to represent with these charts were, the participation of the major in total, the total students, as well as the breakdown in men and women. But one can make a very strong argument that that third total column actually just makes it more difficult to read than anything else, but I'm trying to depict both subcategories and a total. But a stacked bar chart is probably the better fit, because now not only do you visually see the comparison between men and women participating in each major, but you also get the total. So that's why your choice of chart really can assist in making your information clear, and that's why a library that has a kind of a laundry list of charts is kind of a value. So all of the charts that we've seen so far basically have the exact same syntax. The only difference is in line 12 of the chart that we create, and the adding the method, the series is all identical. And that's how it is for most, or a good chunk of the charts, until you get to things like the scatter point or the XY. That in particular we created in line 5, but you'll notice that when we add our components, we're specifying a label followed by a list of tuples representing X and Y. So that's the subtle difference. So you can't necessarily just jump back and forth from all charts, but different chart families you can basically migrate back and forth to. And who doesn't love a pie chart? The one in the back is so busy that you probably couldn't understand it anyway, because I'm trying to depict everything. But that's partially why a lot of the time you'll just try to limit your charting to the top 10 or so. And that's precisely what we did here. Line 5, we created the pie chart, and then we basically added the values. But you also will notice, so pretend that you're in a classroom, you've got no computer, and you want to generate a pie chart. The way that you would do that is you'd write all your values on a whiteboard or a blackboard, then you'd sum them all up, and then for each one of those values you try to figure out what the percentage is. Then you draw a big old circle and try to draw a slice of the pie representative of the percentage for each one of the values. But you'll notice you don't have to do that. You don't have to do the summation, because PyGal will do it for you. Here we just specify the values. They can be floats, they can be integers, and the summation is done for you when you render it into the browser. This slide is exactly, or the graph is exactly the same as the last one, only because it's just a static image. If this was in a browser, it would be a little more apparent. But you will notice up until this point, all we've been adding is values, right? A list of values. But sometimes you want your chart to actually represent more than values. So you can actually apply labels as well. And that's the intent of this subtle change. We basically, rather than just specifying a list of values, we specify a list of JSON-ish elements. And now, you'll see this in the next slide, but when you render it in the browser, when you hover over each one of these pie segments, then that label will present itself. And that is kind of what you can see in that active GIF, hopefully. But this one's a little different because it's a multi-series pie. And you notice that it's a pie chart, except on the outer ring, it's got this line segment distinguishing between the sub-value, or what do I want to say? Subcategories is probably the term I would use. You notice we're in zoology, we're basically applying two different data values, one for men, one for women, and because we're doing that, the full slice of the pie represents the popularity, if you will, of zoology as a whole, but then those outer segments, when you hover, will tell you the breakdown of men or women or whatever your subcategory actually is. I'm going to do a pause for the cause. Everybody tracking?
Yep.
All right. This next graph, I wish I would have known about this forever. And I've only recently become aware of it, but a lot of the time when people are interested in almost anything statistical, one of the first things that they're interested in is tell me the range, min-max, and tell me the mean, if you will. That's a relatively good starting point to understand how the population is. And then if they're fancy, right, I've long forgotten much about statistics, but they may ask for the variance or the standard deviation. And all of that is actually essentially given to you by this choice of chart. These whiskers essentially identify the range of the values. The line in the segment in the middle is actually the median, so it'll tell you about where the middle is in terms of the samples. And then it might be a stretch for me to say that the box is a standard deviation or a variance because I'm not 100%, but it basically identifies the variability in the sample. So a wide box implies that there's probably a lot of variability between samples, and as it's tighter, it kind of implies that the values are kind of bunched together. I don't want to speak too definitively about that because I still have to do some research and understand the subtleties of this box a little bit more, but those are my kind of takeaways. And I'd welcome anybody more knowledgeable to
the labels show you that the box ends are lower quartile and upper quartile. So that means that that's where 25% of your data points are below that at the lower quartile, and upper quartile, 25% of your data points are above it.
Okay. Obviously, you have more experience with this, so that's great. I'm really looking forward to actually understanding this a bit better. My statistics is very, very rusty. Is there anything else you can offer? Okay.
I've seen some box plots where there are outliers that are also shown that are outside the range, as sometimes they show those individual points. And also I've seen variations where instead of the median, the mode of the distribution is estimated. So there's a couple different variations of this type of plot.
Yeah, and I have to dig a little bit because you'll notice that most of the examples I'm using are kind of with default. It would be interesting to know whether PyGal can actually do those alternatives.
I think these are technically called box and whisker plots.
Okay.
if the median is in the middle of the box, it tells you the data is evenly distributed. So if you look at the first picture, there the data is quite skewed. You can see that line is not in the middle of the box. As somebody remarked,
Right here.
if you look at the box, above the line, that's 25% of the data. Below the line, that's the other 25% of the data. So it tells, and then typically from the top of the box to the whisker, that's another 25%. The bottom of the box to the lower whisker is the last 25%. One remark I think somebody mentioned, I think it's maximum subject to that there are no outliers. So yes, if your data is reasonably distributed, this captures 100% of the data, but otherwise it throws in some dots above the upper whisker and below the lower whisker.
Yeah, I apologize, and I even kind of glossed over the fact of what we're actually trying to represent. In this particular case, we're trying to represent the salary ranges. So unless there is anything else, we'll move on to another one, which would be the histogram. I feel that this chart is really kind of clumsy. It's probably not a good fit for what I'm trying to represent, but remember I was trying to find a data set that I could kind of show everything. Just like the box the scatter point as well, you'll notice that as you add these elements, they take a different form. You notice that when we add to arts, it's actually you're specifying your y value followed by two x values, the one to the left and the one to the right, and that it's rendered by drawing a box using those 3 points essentially. It feels like a very clumsy use of histogram, but I at least wanted to kind of demonstrate how that could actually be done. Then another one is the dot, dot graph. This, like others, is kind of a way to try to represent, three-dimensional information where the size of the dot is kind of giving you additional information. But before we get into that, you'll notice on line 17 are X labels, or what I've been referring to as categories. Those aren't numerics anymore. We're specifying a list of strings. So this gives you the opportunity of actually laying out the participation of men and women rather than representing it as a numeric, if you will. And just at first glance, if you're to focus on the women category, just the size of the dots kind of imply the popularity. So it's probably reasonable to say with this study that electrical engineering is more popular than chemical engineering and mechanical engineering. Whereas with the men, chemical engineering is probably the least popular, or not popular, I should say, less students is what I should say. Followed by electrical engineering, and really mechanical engineering for this study being probably having the most participants. In the ad, it's basically you're just specifying the value kind of in the same manner as you would with the pie charts.
I got a quick question about your try except there. Just wondering, like, what were your reasoning behind setting it up like that?
Just to try to make sure that you notice that the plot data dictionary, for any particular category, for that major. Okay, let me try that again. When you first try to add plot data 2316, when it doesn't exist, I'm basically trapping it in the accept, generating the list, and then appending thereafter. So it's basically just trying to deal with the not exist case, clumsy as it is.
Oh, gotcha. So yeah, there's not a value for the key. That's
right.
What it's doing?
Yes.
Gotcha.
Anything else? I stripped out all of my code comments, you know, just to make me invaluable. No, actually, just because you can't fit much. I find it difficult to actually fit code into these slides, so it's a great question. Only two more left, and this radar plot, I've seen variations of this years and years ago. It also kind of feels clumsy how I'm trying to use it, but you know, you basically got 3 dimensions here and trying to represent how this series fits into that. With the origin in the center, the employment rate kind of coming out here, men and women, it's a means to depict, you know, participation of a series on all 3 axes. Maybe a poor person, I was going to say poor man's view of a 3-dimensional plot. But if it's the best example I could think of with the data set in question. You notice that it comes in as when you add this, you just add the, I don't want to, I guess I'll just say values for each one of the axes in order. And then the last one, and actually part of the reason that I was kind of drawn to at least looking at PyGal is it's got a sublibrary that supports world maps. Up until this point, you know, I would use matplotlib, and if I wanted to do any geographical information, you can render dots over top of a PNG, and that just felt really clumsy to me. And I never found any better alternatives, but then when I came across this Coursera course, they were basically using a world map, which can be is an add-on, if you will, and gives you the opportunity of basically trying to render, in this particular case, the participation rate of secondary schools by country. Not a lot of real detail in this graph, but I at least wanted to demonstrate that this is probably one additional thing that beyond the 2-dimensional graphs that we've been seeing up until this point. That is actually it. The references, official site of PyGal, I'd certainly welcome you to take a peek there. The 538 CSV is located in their GitHub. And then that last world chart, this world development indicators is a pretty lengthy data set, again CSV, and that was valuable in generating the previous slide. I will slap the slides out in this location, as well as I'll post that in the meetup in case anybody wants to refer to them. I have a lot of interests, but most of them in computers and software. I write a blog or tech blog, so if you're interested in any other ramblings, I invite you to take a peek. And I go under lapel GM on Pymntos /Chental.